Hello and welcome to this lecture. We're now going to dive deeper into generics, and you've been using them so far in this course while you were working with collections. But we need to dive a bit deeper to fully understand how they can be useful in your Java code. Now, several lessons ago when I introduced the array list, you saw that if we create an array list and don't specify the type parameter, meaning, in those angle brackets, if we don't specify the kind of data that can go into that array list, we could run into some trouble. Now let me quickly revisit that before we move on to the specifics of generics. Here I have the project More Generics. I created it sort of on the fly, and you can do the same. I have a package here called Client, and I created a class called Application with the main method in here. So let's just quickly define an array list, and I'll call it myList is equal to new array list. Notice that I didn't use the type parameters. Those angle brackets, I'm not specifying them here. Let's do the Control-Shift-O to bring in the import. Notice that Java is giving us a warning. If I hover my mouse on the array list, notice it says array list is a raw type. References to generic type array list should be parameterized. So it's basically saying that this is a raw type. Be careful how you use this thing. And what it's warning us about is I can add anything I want into this collection. I can do mylist.add and then put in the word hello. All right, I could do that on one line, and on the next line, I could do add an integer. On the next line, I could just go ahead and, add a Boolean, such as the value false. So I'm adding different data types into this collection, and it's warning us that, hey, you're using the raw type, meaning that anything that goes in here will be considered an object. It won't be considered the type that you intend to put in here. In other words, if I want to extract one of these data points, if I do mylist.get and I specify the 0th index position and I assign it to a variable, we know that it's a string, and I can say myVal is a variable name. Notice that it's complaining. Hover your mouse here and saying type mismatch. It's basically saying, hey, what do you mean that this is a string, right? It doesn't know the data type. So we have to literally cast it. We have to specify that this is a string, and now it will not complain. But here's the thing though. Let me copy and paste this on the second line, and I'll call it myval2, and I put the index position 1. Notice we've got a problem here. At the first index position, that's this guy right here, the second value in this list, we know that it's an integer. But Java has no way of figuring out what data has been added to this array list. And we can, we're basically fooling it by saying there's a string in here, and we are taking the value, casting it, and putting it here, even though it's actually an integer. So again, the error, hover your mouse on array list, it's saying array list is a raw type. References to generic type array list with the angle brackets, E, should be parameterized. So if you control click the class, let's go to the top. Notice that this class is a generic class. Look at these angle brackets, okay? So it wants us to specify what kind of data is going to go in this class. That's why you see these warnings, these yellow, squiggly lines underneath. So let's specify the kind of data that's going to go in here, string. And now that error up there went away, right? The warning is no longer there, but these two guys are no longer allowed, okay? We can't put in an integer into a string, and we can't put in a Boolean into a string collection. This allows more type safety. Now the Java language is all about types. Okay, classes are considered types. Abstract classes, they're considered types. Interfaces, right? These are all considered types. And what I mean by type is that you can, declare a variable, and its data type is going to be either a class or an interface, right? You specify the type for that data. So this is the variable, and we're specifying the type. And since Java is all about types, it was designed to be type safe. In other words, it sort of babysits the developer to make sure the developer knows what the data type is that they are working with, right? So for example, if the developer, assigns an integer, some number, to a variable that is of type string, the Java compiler is immediately going to bring that up. It's going to complain immediately while you're coding up right here in your IDE. So that's actually a beauty of type safety. Rather than finding the errors during runtime, type safety is ensured during compile time. Now, because there is this babysitting going on with regards to type safety, the Java language previously seemed overly restricting with what a developer can do with object-oriented programming. So generics were finally introduced in Java version 5 to allow more flexibility when designing your programs. Generics keep the promise to allow the developer to be flexible without sacrificing the benefits of type safety, okay? And that's exactly what we see here, right? Take a look at the ArrayList class, control click, right? It's flexible enough to allow any kind of data type to go in here, right? We specify the type parameter. We're specifying here that, a string can go into these angle brackets. I can, define my own user-defined class that we saw earlier, and I can give that class in these angle brackets. So the ArrayList class allows flexibility on what can go in here, but at the same time, it ensures type safety. That's the beauty of generics. This is considered a generic class, the ArrayList. So is the hash map and some of the other classes that you've worked with so far in this course. So now let's go over how to create a generic class, and then we're also going to talk about generic methods. Generics is an advanced Java syntax. So this is really the only part of the language that's sort of holding you back from going knee-deep into the Java native libraries, reading through the ArrayList code, reading through the linked list code, and so on. So once you understand generics, your fear of reading Java code will certainly be eliminated, okay? Here we are back in the application class. I've gotten rid of the code that we had there before. And now we're going to talk about how to create a generic class, and then I'll move on to creating a generic method. So right-click here in the same package client. Just right-click and go to New Class, and we're going to create a class called Container. Let me define two variables here. They'll be of type string, and I'll call it item1 and string item2. Let's also add a constructor, and of course we need to assign the different fields. So far, this class is only capable of working with strings. Let me define one more method so we could do something with this. We'll just say print items, and we'll specify what item1 is, and we'll do the same for item2. So this class right now is only capable of working with strings. Without using generics, how would I make this class be able to work with any user-defined type? What if I wanted to make this class work with integers or, booleans or, some other number, or even a user-defined type, for example, some other class? Instead of specifically saying that the item1 is going to be a string and item2 is going to be a string, I can change this to be object, okay? And right now we're not using generics, right? I haven't used those angle bracket syntax anywhere. I've changed the type for these variables to be object, and nothing is complaining so far because string is in fact an object. So it's not going to complain. Let me also change these to object and change this to object. Okay. Now I can use this in somewhat of a generic way. I can say container, and I'll just call it container is equal to new container, and then pass in, for example, the number 12 and the string hello. Okay? Both of these are children of the object class. This integer as well as this string is in fact an object. Everything is an object in Java, right? So it's not complaining at this point. If I was to add a getter to this class, I could just quickly go to source and generate getters and setters, and we'll just select all. Notice that these get item1 and get item2, it returns an object. So if I wanted to say container.get item1, and we know that item1 here is an integer. If I do int, my var, it's not going to allow me to do that. It wants me to specify this to be an object, right? We've seen this before with, working with collections. So this class is somewhat generic. I can use it to put integers, doubles, any user-defined type, but it's not type safe. We know item1 here is an integer, but if we take it out as a string, if we cast it as a string data type, the Java compiler would not know the difference. As far as it's concerned, everything is an object, so whether we cast it to an integer or a string, it doesn't matter. Notice that it's not complaining even though we know that this is an integer. So how would we make this class generic? We use the angle brackets and specify the kind of data that this will have, the types of data that this container will have. And we can call it I1 and I2. And so this I1 and I2 could be I1 here and I2 here. So now item 1 and item 2 is capable of being any kind of object, whatever type parameter is used, okay? And the same thing goes for these arguments. We have to put I1 and I2. Okay, so now the constructor is passing. All of these others, they're going to complain because an object, we can't just be an object, it needs to be using this I1 or I2 type. So we need to change this to I1 and change this to I2. And now this class is completely generic, okay? If we go back to the application class, if you hover your mouse, it's going to say container is a raw type. So we're using the raw type version for this class because we're not specifying the type parameter. That's what the warning states. So let's indicate that these are going to be integer. That's going to be the first argument, and string is going to be the second argument. As you can see right here, this is the first argument and this is the second argument. Item 1 is going to be an integer, item 2 is going to be a string. And at the constructor, we need to make sure we use the angle brackets to specify that we want to use the parameterized types that we are specifying here. If we don't repeat those angle brackets, it's still going to treat this as the raw type, okay? See, it's saying container is a raw type, so we need to specify the angle brackets so that we're not using the raw type. Now, we can say container.get item 1. And one thing I forgot to change. Let's go back to item 1, the get item 1 method. It's not returning an object, it should be returning I1, okay? And same thing for down here, item 2 should be I2. And now this can enforce the proper types. I can say that the value for item 1 is of type int, and I'll just call it val1. And notice that it's not forcing us to cast it to anything. It understands that it's an int. And same thing with the second field. Item 2 is not an integer, right? Item 2 is not an integer, and it knows it. This is compile time type safety going on here. It's checking for us, making sure that we don't make a mistake. All right, it's saying type mismatch cannot convert from string to int, okay? Because we stated that this is a string, right? The second type that is being used in the class is a string. When we try to get that field, item 2, it's complaining and saying, hey, this is not an int, this is a string. So we need to change this to a string. And now it's working fine. So do you see how generics keep the promise to allow the developer to be flexible enough, right? We can put anything in here. We can use this container to save any kind of objects, whether it be strings, doubles, or user-defined classes. We can use this container for anything as long as we specify the types. So generics keep the promise to allow the developer to be flexible without sacrificing the benefits of type safety. Issues related to types are highlighted at compile time rather than runtime. So I showed you how to convert a pseudo, before it was a pseudo generic class. It wasn't really a fully generic class. Now this class is completely generic. Okay, it's based on whatever types is passed into the angle brackets. So the container is a generic class, and we can pass in any kind of data type in here. And that's going to take the place of wherever I1 is and I2 is. So here, integer is going to take the place of I1, and string data type is going to take the place of I2. So wherever we're defining variables or referring to this I1 and I2 in the method definitions and in the the types for the parameters, everywhere where you see I1 and I2, that's going to take that place respectively in that order as we're passing it here in the angle brackets. Okay, so that's a generic class. Now let's talk about creating a generic method. Outside of main, I'm going to create a method, and we're going to call it union. And it's going to be a static method. And the return type is going to be set. And the method name is, of course, union. And it's going to take two arguments. One is set, we'll call it set1, right? That's the parameter name, and this is the data type set. And you've already seen sets, from the previous lessons. The second argument is set2. Okay, and what this is going to do is going to union both of the sets together and return a result. So if set1 contains 1, 2, 3, 4, 5, and set2 contains 6, 7, 8, 9, 10, the return value of this set is going to contain the numbers from 1 to 10. And remember, sets do not store duplicates. So if there are any duplicates, it's going to disregard them, and we're only going to get unique values in the returned result. So let's just do a quick Control-Shift-O to bring in the import for the set interface. And I'm going to define a variable in here called result. That's going to be of type set, and we're going to do new hash set. And you're probably noticing that right now, this is not a generic method. To the argument of hash set, when we're instantiating this hash set, we're passing in set1. So that result contains the values that are in set1. Let's do the Control-Shift-O to bring in the import for hash set. And now all we have to do is result.addAll. You've seen this from the previous, collections lessons. The addAll method adds everything from another collection. So we could just pass in set2. And after this line, the result variable will contain the data for both of these sets, and it's going to disregard duplicates. So we could just return result. And now this method should be compiling. So notice all of these warnings. Hover your mouse, and it's of course saying, we're using the raw type. We're using the raw type. It's saying that on pretty much all of these lines. And that's a problem, because if anyone uses this method without the regard for the data types, one set can contain strings and the other one could contain integers, it'll still be able to add that to the result. But if we try to get those values and do stuff with it, we're going to have trouble, okay? Because we're going to be iterating over things that we don't even know what those data types are. And we can have class cast exception issues, exceptions taking place during the casting process. So to convert this non-generic method into a generic method, there are a couple of things we need to do. The first thing is we need to pass in those angle bracket syntax to the parameter variables. So set1 is of type set with angle brackets with some value. This unknown type. Right now I just gave it the variable e, just like in the container class how we gave the variable I1. Over here I gave the variable e to represent whatever data type is going to be used for this set. And then for the second argument is also going to be e. And wherever e is used in the body of this method, right now I haven't used it, wherever it's used, it's going to take that data type in the definition of this method. So right now it's giving an error because right now it doesn't know what e is. Hover your mouse over here and it's saying e cannot be resolved to a type. It just doesn't know what e is. So we need to actually define the type for e. And another thing is, if this is taking in two sets with the data types of e, then it better return the data type for e. So the return type for this method is also going to be set with the e data type. And we're almost there. We're not done yet with this, with the signature of this method. There's one more thing that we need to do. We need to define what e is in this method. All right. And I'm not talking about, defining whether it's going to be a string or an integer or some double or some other data type. We want this to be generic. We want this to be usable for any kind of data type. And to let this method know that, hey, we're going to use you as a generic method, there's a very important piece to this, and that's going to be defining what e is. And where do we define where e is? We just define it out here, like that, okay? This is going to take a little getting used to. When you look at this code, you're going to see all these E's with angle brackets. It might be confusing at first, but it's important to understand that over here, we need to specify that, hey, we're going to be using this E inside of the method body and the method signature, and we specify that right here, right before the return value for this method, right? This is the method name. This is the return value for this method. And then over here, we are specifying that we're going to be using E inside of this method. If I change this to some, T, we still have a problem. It doesn't know what E is, right? It's showing the red squiggly lines underneath these E type parameters. So we have to specify E out here, and think of that as we're sort of defining that E has a significance inside of this method definition as well as a method body. So the rest is actually very simple. The set that we're referring to here also better utilize the same data type. And of course, when we're defining the hash set, we need to also specify E right here. Okay. And again, as I spoke about a couple of lessons ago, after the new keyword, if you're using Java 7, after the new keyword, when you're instantiating a particular collection or generic class, such as the hash set, we don't need to repeat the contents of the angle brackets. We can leave them out, right? Like I'm doing here for container. I left out from the angle brackets this integer and string because since I'm defining them as the data type for this variable, Java is smart enough to know that we're going to have these same things inside of this angle bracket. So it's just a little less syntax for the developer, which is a good thing, because if we had like 10 different data types inside of these angle brackets, we'd have to repeat them for, after the new keyword, and that'll be a really long, lot of code basically. So the Java community for version 7 had this upgrade that you don't have to repeat those data types for the second set of angle brackets. And that's why over here, I don't have to repeat in the second set of angle brackets this E, right? But for the sake of clarity, I can do that if I want to, okay? And for this example, I'm going to leave it here. And that's it. This is now a completely generic method. And if I want to use this method, I can create two sets. We'll call it a set of strings. And we'll call it mySet1 is equal to new set of strings. And of course, the second part needs to be the actual implementation. This is the interface. We need to actually have the implementation. You should know this from the lectures on object-oriented programming. So we specify the actual class, hash set. And now let's give mySet1 some data. We'll give it, some random words. I'm just going to call it first and repeat that here a couple of times. First, second, and whatever. Okay. And I'll just copy paste this to save time for set2. All right. This is going to be called mySet2. This is also string, and it's going to have, instead of the third word being whatever, I'm just going to call it computer. Okay. So a quick quiz. What do you think is going to be populated in result? When I union set1 and set2 using this method, what do you think is going to be returned when I call the union method, passing in mySet1 and mySet2 to this method invocation? Well, I expect 4 words to be populated using this union method. And there's going to be first, second, whatever, and computer. Because this first and second here are going to be duplicates, and the result hash set is going to ignore those when we try to add in the second set, because sets do not contain duplicates, right? That's just a quick revision. You should already know this. So I could just call union and pass in mySet1 and mySet2, just like that. And the return value for this, I'm going to store it in a variable called result set. Now over here, it's giving us a warning. Hover your mouse over the set keyword saying we're using the raw type again. So all of this hard work that we did would not be of any use to us unless we specify that the data that's coming out of here is of a specific type. Because when I do things with the values using the result set, it's going to consider them all objects. So I want to make sure that I specify that it's going to be string data. And now to iterate over the result set, I could use the iterator. And this is another way of iterating over collections. Instead of the for loop, we could use the iterator. And every collection class has this iterator. And I'll show you how to use it. We can do result set dot iterator. And now we can use this variable called itr to iterate over the values in this result set. Let's do the Control-Shift-O to bring in the import for the iterator class. And now to iterate over this whole thing, we can do while itr.hasNext. While that's true, it's going to iterate over the values. And I'm just going to print out those values. We'll invoke the next method on the iterator. So let's hit play to make sure it's working. And there you go. We have 4 words that are printed. Now notice something here. Notice that there's a warning underneath iterator. Hover your mouse and it's saying iterator is a raw type. References to generic type iterator with the E type parameter should be used. So what's it saying here? Well, it's saying that result set contains a list of strings, right? So because of that, it's saying that, hey, result set actually is a list of data that is of type E, right? Whatever that type is, it's supposed to be generic. And in other words, it's a list of type strings. And right now we're using iterator without specifying the type of data. It's printing data just fine, but if I wanted to use these values, let me get rid of the print line statement here and try to do something with this. So we do iter.next, and if I want to get the value, we know it's string, right? We put strings in there. If I define a variable called, we'll just call it var, I'm getting the value from the iterator by invoking the next method and assigning it to var, but we've got a problem. Notice that there is an error. Hover your mouse over here and it's saying type mismatch, cannot convert from object to string. Okay, so when we're getting the data from the result set, when we want to loop over it using the iterator, we want to make sure that we use the generic version, not the raw version. Right now we're using the raw version. And I'll prove it to you. Let's click on, control-click the iterator class and notice, well, it's an interface, but anyway, notice that it has a type parameter. It's meant to be used with some data type. And it's up to the programmer to choose whatever data type they need to use with the iterator. And if you don't use it, it's going to give us a warning. Because later on when we use it down here, it's going to force us to cast it. So now I have to cast it like this, and only then it's going to work. So to prevent casting and to make sure that type safety takes place during compile time when we're coding, we want to make sure we continue to use these angle brackets and specify the kind of data that we are working with. Okay, and now that error or that warning on iterator has disappeared because we are using the correct data type. So again, what's the beauty of this? Well, if I mess up for whatever reason, I put integer here, the Java compiler is smart enough to know that the data that's returned is not a list of integers, it's a list of strings. So of course it's saying type mismatch cannot convert from iterator string to iterator integer. So when we invoke the iterator method on the result set, it's going to return the data of the type for result set, which is a set of strings. So things are type safe when we use generics. And now it's compiling just fine. And I could just print out the value of var like that and we'll get the same result. So let's hit play and boom, there you go. It's working as expected. All right, so we've covered a lot of ground in this lesson. I don't want to flood your brain with too much information in just one lesson. You should review this if this is a bit challenging. And it might be in the beginning, don't worry. It's going to take some time for you to grasp it 100%, but it's all about the practice. So make sure you're coding along. But the big idea behind this generics thing is we can use them for method definitions, right? Over here we have the method called union, and we are declaring that we're going to be using a generic type parameter, and we have to first define it. And where is it defined? Quick pop quiz. Where is the generic type parameter defined in this method? It's right here, right? This E, we're saying that E has a significance inside of this method. Anywhere where you see E is going to be the type that is specified in the argument. And because it'll be passed in as an argument to this method, that E is going to be used inside of the body of this method. Wherever you see E, that's going to be the data type that was passed in to this method, okay? I could have made this T, all right? And then it's not going to compile because all of these E's, it doesn't know what these E's are. All right, so the type parameter that we specify here is meant to be used in the body of this method. Now I can have E, I can have multiple, I can have V, I can have O, whatever I want, all of these letters. I can specify that each one of these letters will have a significance in this method. All right, it's compiling right now because we have E here and we're using E. It's not complaining. Even though we're not using V, O, G, these are just random letters that I came up with. They could be anything. They could be, words. I could just type whatever. I can make these anything I want, any legal variable. But if I use some variable in here, or the type parameter in here inside of these angle brackets, such as the word hello, we've got a problem because hello is not defined out here. This is where we define the type parameters that will be used inside of this method. All right, and hello, we're using it here, but we're not defining it out here. So it needs to be part of the method definition out here. This is where we specify the type parameters that will be used inside of this method. Now, of course, this is not going to compile the way it is right now because hello here has nothing to do with E, so it's not going to work. So let's just change this back to E the way it was, and let's get rid of all of this other stuff. All right, so hopefully that makes sense. These type parameters, you can name them anything you want. Typically, a single letter is used. You'll see in the Java API certain letters being used. For example, the array list has E for element, that represents element, capital E. You also see a bunch of T, capital T, to represent types. And for hash maps, the capital letters K and V being used. K represents the data type of the key, and V represents the data type of the values for a hash map. Over here in our container class that we created, right, we're passing an integer and string. Integer will take the place of I1. So wherever I1 is in this class, it's going to represent the integer, and I2 is going to be the string, and wherever I2 is in this class, it's going to be the string data type. So these are type parameters, and they could be words. Best practice is to use single capital letters. That's the convention. I broke the convention here just to prove a point that you can really have anything, any legal variable inside of these brackets. So again, back from our object-oriented lectures, when I was talking about the fact that a class is a specification, it's a blueprint. This is a class, okay? It's a specification, it's a blueprint, a template, so to speak. And we're specifying that these type parameters are part of this template. Wherever these are used, some data type is going to be replaced there, okay? This is a specification for what a container is. When we use this specification here in our application class, we're using this specification. We're calling it new container. We're instantiating a new container, and we're specifying that, hey, this particular instance is going to be using the integer as well as string. Later on, let me just copy paste this. Down here, I could specify a new container. We'll call it container 2. This is a new instance, and in here, I could say that this is going to be a double, and the value here is going to be integer. So these are two different instances, container 1 and container 2, but we're using the same template of the container class, and these two values, double or integer or string, are going to be taking these the I1 and I2's place respectively. Okay? And this, of course, is not compiling because double is usually a decimal number, and we have a string. So let's change this to an integer. I'll make it 300, for example, and let's put a decimal like that. And now this is compiling. So we're using the same specification, right? Same class definition with two different types of data, right? And that's what generics allows us to do. And you can use generics for classes as well as down here as we did for the methods. For classes, we define the generic type parameters after the class name, like we are doing here. Right? This is where we're defining the type parameters that will be used inside of this class, okay? This is where we're defining the type parameters, and over here in application class down here, we have a method, union. Where do we define the type parameters for methods? We define them right before the return value. This is what this method is supposed to return, and right before that, we are defining the type parameters that will be used in this method, okay? So a lot of information covered in this lesson. Make sure you review it, watch it over if you have to. These are fundamental generic concepts that you must understand. There's a couple more things we have to talk about with regards to generics, and I'm going to save that for the next lesson. So stay tuned. Thanks for watching. I'll see you soon.